Thank you so much for taking the time to do this interview with me today. To reiterate, my name is Annie, and I created Sustainability Beyond the Lab to highlight sustainable technologies and make them more accessible while explaining the barriers of translating this research into real-world impact. To start, could you please introduce yourself, your innovative concept of the techno-ecological synergy, and tell us about your research at ASU?
Sure. So yeah, thanks, Annie, for your interest in this and for the opportunity to chat with you. My name is Bhavik Bakshi, and I'm a professor at Arizona State University. Yeah, I hold positions in three departments. My primary affiliation is with chemical engineering, which is what I am by training. But I'm also in the School of Sustainability and the School of Complex Adaptive Systems at ASU. And the research that we have been doing is essentially aiming to develop methods, manufacturing processes, and also products, also life cycles and supply chains to ensure that the results of technology, specifically chemicals and materials, are sustainable. And one of the things that we have developed over the years is this concept that you mentioned of what we are calling techno-ecological synergy. And the idea over there is that if we think about sustainability, to sustain anything on planet Earth, the one entity or the one resource, if you like, that we all depend on is nature. Basically ecological systems. And traditionally, engineering, well, pretty much every discipline except ecology has ignored the role of nature. So the idea behind the techno-ecological synergy is to explicitly include the role that nature plays in supporting human and industrial activities and try to design systems that can be mutually beneficial. So industry benefits and nature benefits. So that would be a synergistic type of a system. So that's the basic idea behind that concept.
Yeah. Thank you for giving that little overview of your research. It's very interesting hearing your perspective firsthand. For audience who might not be familiar with sustainable engineering or life cycle
Mhm.
analysis, what problem is this field working to solve, and why is taking a systems level approach so important?
Right. So I'll give a very simple example that is kind of current also. So, a lot of people are, have been talking about, say, electric cars, being more environmentally friendly or even more sustainable. And primarily that is because they don't have a tailpipe. There are no tailpipe emissions from electric cars.
Mhm.
As compared to, say, gasoline-powered cars, which do have a tailpipe and will emit carbon dioxide and other pollutants. But if we just look at the car itself, then this conclusion that one might reach of electric cars being more sustainable might actually not be correct.
Mhm.
Because the emissions, many times, these environmental problems are quite complex. The problems tend to shift in many ways. So even though the tailpipe, or there is no tailpipe in electric cars, the emissions may simply shift upstream of the
Mhm.
driving of the car. So they may just shift upstream to the generation of electricity. So if electricity is being generated from, say, coal or natural gas, from fossil resources, electric cars are not necessarily better than
Mhm.
gasoline-powered cars from a carbon dioxide, from a greenhouse gases point of view. Okay, so to understand sustainability, you can't just look at a small system. You have to look at the system, I mean, the product, the technology, and its wider,
Mhm.
supply chain and use chain, or what could be called value chain, or is commonly referred to as a life cycle. So you need to
Mhm.
consider all the way from extraction of resources, all of the steps to the manufacturing of the product, use of the product, end of life of the product. Is it getting landfilled? Is it getting recycled? What is happening? You have to look at the whole picture to make sure that you don't end up shifting a problem from one point to another, but are really able to solve it. So that's why a systems view if necessary. And that's basically what life cycle assessment does.
Mm. Yeah, it's really interesting with especially perspective on how we consider electric cars more sustainable, but we don't consider the upstream emissions. But
Mhm.
yeah. I've noticed one theme of your research is integrating natural ecosystems into engineering design. Could you
Right.
explain what this means and why it represents a shift from traditional engineering?
Sure. So I'll also give an example over here.
Mhm.
So if you think of any say manufacturing process, okay, so you may be generating, it could be a power generation process, it could be a process that is making say polymers, it could be a process that is making fertilizers, could be any of these kinds of manufacturing processes. It could also be processes that make say cement or steel, pretty much any manufacturing process.
Mhm.
Okay. So manufacturing processes in general require energy and water. Okay, in addition to the raw materials that it is converting into the product, energy and water are the utilities that are essential.
Yeah.
Okay, and the processing typically results in emissions. So you would end up with wastewater, and you would end up with emissions that go to the air, and there may be other emissions that go, to the soil and all that also.
Mhm.
So the idea behind accounting for or including ecological systems is so if you have emissions that go to the air, I mean, typically there are regulations that need to be followed, and you cannot emit, more than the regulated limit. But that still results in plenty of pollution
Mhm.
that can be quite, problematic, and in the United States, but also I mean, all over the world, basically. So trees, it turns out vegetation in general has the ability to take up all kinds of emissions that go into the air. So trees will take up carbon dioxide through photosynthesis. I think that is very well known.
Mhm.
But trees will also take up other air pollutants like sulfur dioxide, nitrogen oxides, particulate matter, and reduce the amount of volatile organics that could be emitted into the air. So trees, vegetation provides an air quality regulation ecosystem service.
Mhm. Mhm.
And usually using trees for mitigating air pollution is a lot cheaper than using technology. Okay, so I'm not saying that we can use trees to meet regulations. I'm talking of reducing emissions beyond regulations.
Yeah.
For meeting regulations, using technology makes sense, but we want the environmental quality to be better than that.
Mhm.
That's where vegetation can play a very big role. Okay.
Mhm.
Not only that, trees can also result in reducing the temperature. So, reducing the amount of cooling and heating that is required, for example, on buildings, in the summer and the winter. And with summers getting hotter, trees become even more important, so that the cities benefit from their cooling impact.
Mhm.
Okay. And very similarly for water. Wetlands are very capable of treating all kinds of polluted water for very little money. Okay, so wetlands are used in a lot of industries and also in a lot of urban areas
Mhm.
for treating polluted water and giving water then that is actually, I mean, that can go back into the ecosystem.
Mhm.
And at the same time, they may also support biodiversity.
Mhm.
So those are some of the examples.
Yeah, it's really interesting to see how like the like nature can benefit us as much as we can benefit nature and how we should consider
Mhm.
that during engineering processes. If I
Right.
can ask, many climate technologies are kind of based on carbon emissions alone for sustainability. What
Mm.
other factors
Mhm.
do you think researchers, policymakers, and the public should consider when assessing whether a technology is really sustainable?
Right. So yeah, carbon is certainly important, no doubt.
Mhm.
So focusing on climate change and greenhouse gases does make a lot of sense. But if the emphasis is only on that, we may end up solving one problem and creating other problems.
Yeah.
So net, we may not really progress. We may actually end up making things worse, even,
Mm.
unknowingly, maybe. So a lot of renewable energy technologies are commonly used, for reducing greenhouse gas emissions. So, for example, using photovoltaic, solar panels for generating electricity instead of using, natural gas or coal-based electricity, right?
Mhm.
And there are many examples, of that type, which are going to reduce greenhouse gas emissions. But the flip side of that is that, all the renewable energy technologies, be they photovoltaic panels, be they wind turbines, be they batteries, so any of the smart grid type of
Mhm.
technologies, they all rely heavily on all kinds of materials. Okay, their dependence on materials is much more than the dependence of materials, from fossil-based technologies.
Mhm.
So there ends up being a trade-off. You can reduce greenhouse gas emissions, but you have to be careful about the materials used and what happens to the materials, particularly at the end of life.
Mhm. Mhm.
Okay, so
Yeah.
looking at the materials is really important. Now, materials in their life cycle also have potentially an impact on biodiversity loss
Mhm.
because of the mining and all that.
Yeah.
Right? There could also be other impacts, in other categories. Could be other air pollutants, could be water use, and so on. So one of the ways of dealing with that is to try to also develop a circular economy of materials. So
Mhm.
that way you rely less on virgin materials, don't rely as much on mining, but you ensure that the materials are kept within the economy
Yeah.
and stay within the economy just as happens in nature.
Mhm. Yeah, I've explored that concept kind of with lithium battery recycling. I've read this really
Mhm.
interesting paper that kind of applies a circular economy. Um, from your perspective, what are kind of the biggest obstacles that prevent these sustainable engineering practices from being widely adopted? And are these,
Right. Yeah, go
sorry to
ahead.
cut you off.
Sorry, can you say the last part? Are
Yeah.
these
Are these challenges primarily based on like the innovation itself, economic,
Mm,
policy related, or kind of a combination?
right? So I mean, it's a combination, is the
Mhm.
short answer. But I'll give you an example. Going to the techno-ecological synergy example that
Yeah.
I gave you about the role of trees,
Mhm.
right? So if trees and wetlands are so good at mitigating air pollution and improving water quality, and they even cost less,
Mm.
why are they not being used more?
Yeah.
Okay, so that's a valid question, right? And the reason for that is because, the impact of pollution is felt by society. Okay, but the cost of mitigating the pollution
Mhm.
is going to have to be borne by the company.
Mhm. Mhm.
Right? So if there's a manufacturing process and they want to reduce their pollution and they're going to plant more trees, well, they're going to need land for that. They're going to have to plant the trees. There's going to be a cost associated with that. Even though it is smaller than using technological alternatives, there is still a finite cost associated with that. So, there isn't any incentive for a company to typically do such things,
Oh. Mhm.
because they are not directly going to benefit. It is society that is going to benefit. Now, they will indirectly benefit.
Mhm.
Okay. But I mean, in general, the reason a lot of these technologies don't get adopted is that, you know, in the kind of economic system that we are following in the world today, as I
Mhm.
mentioned earlier, we take nature for granted. We ignore the role of ecosystems, right? So even though ecosystems are providing us all these services, from an economics and from a market point of view, they're free.
Mhm.
We don't pay any money for them,
Yeah.
right? So any impact also is considered to be free. I
Yeah.
mean, so basically the prices that we use don't incorporate the negative impacts of conventional methods.
Mhm.
Because of that, the more sustainable methods economically oftentimes don't end up being very competitive.
Mhm.
Okay, so the
Yeah.
problem is not a technology only problem. It becomes more of an economics and almost a political problem,
Mhm. Mhm.
because, I mean, governments are reluctant to do full cost accounting of various technologies, and so on.
Mhm. That's really interesting to hear, like, especially on like economic incentives, how we take nature for granted and abuse the fact that it's free. I think,
Hmm.
is there any emerging area of research that you think has the greatest potential to transform like sustainable engineering over the next 10 to 20 years?
Yeah, so one area that has already emerged,
Mhm.
and has had a huge impact is renewable energy,
Yeah.
right? So, I mean, solar energy is so much less expensive now. If anybody's going to put up a new power plant, solar tends to be the cheapest option.
Mhm.
Okay, it's cheaper than hydro, cheaper than wind, cheaper than coal, cheaper than natural gas, cheaper than nuclear.
Yeah.
So now obviously solar is intermittent. The sun doesn't shine all the time, right?
Mhm.
So you do need some infrastructure that will provide the base load in
Mhm.
terms of electricity, and that can be provided. A lot of technologies for that. I mean, you could have natural gas burning power plant, but you could have batteries, and you could have pumped hydro, and there are many
Yeah.
different technologies which are all going to develop,
Yeah.
in the foreseeable
Mhm.
future. So I think that whole area is going to grow a lot. I mean, most of the technologies are there, and even economically, it is making sense now.
Mhm.
So a lot of in a lot of places across the world. So in California, for example, there is a lot of effort towards establishing these so-called smart grids.
Yeah.
I'm in Mumbai right now. So India also, a lot of the new energy installations are solar.
Mhm.
A lot of rooftop solar and so on. And here also, that whole smart grid and all of that development is a very hot area of implementation.
Mhm.
Right now, a lot of government support is also going, into that. Obviously, China has already done this, in many places, more than pretty much anywhere else in the world at this point, right?
Mhm.
So that is in the foreseeable future, very immediate future. That I think is one of the technologies that is really going to grow. The other area, maybe it's a little bit longer term, is this whole area of plastics is a major challenge,
Yeah.
right? And plastics have all kinds of unintended, side effects. And this issue of microplastics and all that going to the oceans and all is really problematic. And there are
Mhm.
also studies coming out on potentially the health impacts of plastics, and also ecological impacts, impacts on biodiversity, for example, marine biodiversity in particular. So
Mhm.
there is a lot of work going on over there on trying to develop new types of materials that ideally should be uh, biodegradable, just like a banana peel.
Mhm.
You throw it away, within a few days, it becomes a part of the soil and actually provides nutrients to plants. Either that or it is fully recovered and kept within a circular economy.
Yeah.
So I think that is another area where there is going to be, a lot of innovation, and hopefully we will find really good solutions over there, because I think that's one of the major, needs, one of the major challenges that the world, faces today.
Mhm.
So along those same lines, a lot of work related to circularization of materials. So I mentioned plastics already, or
Yeah.
polymers, but similarly, for metallic stuff also. So as we mentioned earlier, batteries, electronic materials,
Mhm.
electrical equipment, all of these are also increasing in terms of their use. So establishment of a circular economy, of that. So recycling of photovoltaic panels, extending the life of many of these technologies,
Mhm.
those are the kinds of things that I expect are going to be seeing a lot of growth in the slightly longer term future. So I'm talking 5 to 10 year time period.
Mhm. Yeah, it's really interesting. I definitely agree with your perspective on plastics. It's interesting to hear how they don't have to be biodegradable, but they could also just go through like a circular economy.
Right.
Um, yeah. And
Yeah, no, exactly. And I know a lot of it is basically, the way that I think when it comes to identifying research problems and approaches, is I think about how does nature do this,
mhm,
right? And
yeah.
nature has circular, closed loop cycles. They're not completely closed loop, but they're mostly closed,
Hmm.
right? So that's essentially what sustainability in a way is all about. We're
Yeah.
trying to do engineering that learns from and emulates nature.
Yeah. Before we wrap up, is there anything that we didn't discuss or get a chance to talk about during the interview that you think is important for people to know about sustainability research?
Yeah, so a couple of things at least come to mind. One is so we are talking, I just mentioned, right? We are basically trying to learn from and emulate nature.
Hmm.
But the world that we live in today, we are becoming more and more distant from nature.
Yeah.
Okay, so what I'm talking about now is not a technological issue, it's more of a human issue.
Mm-hmm.
Okay, I guess technology is also associated with it because what we are doing is living more and more in the virtual world, right? Which in many ways is great. It's allowing us to talk even though we are, almost 10,000 miles away, right? So that's amazing and really good, to have. But people are losing contact with nature and have less and less appreciation for what nature does for us.
Yeah.
So in that situation, how are we going to learn from nature if we don't even know what nature does for us on an everyday basis? Learning from nature and trying to emulate it at a technological level is going to become only harder,
Mm-hmm.
right? So I think one major challenge that we have and opportunity, is to actually spend some real time, not virtual time, real time in nature,
Hmm.
you know, go hiking, look at the birds, identify the local plant species, local insects, things like that, right? And I think it's also a remedy for a lot of emotional and mental well-being
Yeah.
types of things, right? So that I think is one major direction where things do need to change. And as I said, this is more of a social and human side of things. I would be the last person to say that technology is going to provide all these solutions. It is not.
Yeah.
Okay, by itself, technology is not going to be able to solve this problem. So the human side, also economics and markets will have to play a role. As I mentioned earlier, we are ignoring the impact in the monetary values that we assign, to products. So that also needs to change. And that is, as I mentioned earlier, it's an economics issue, but economists have figured out what the solution is. It's primarily a political issue now. Some countries are doing it better than others,
Yeah.
and I don't want to get into politics, you know,
Yeah.
but that's also another major challenge and a serious need because without that, serious progress is not going to be easy.
Mhm. Yeah, I definitely agree with the political side as well. Not getting into the details, but yeah.
Right, right.
Yeah, thank you so much for sharing both your research as well as your perspective. It was really interesting hearing this from someone so involved in sustainable engineering and having a lot of expertise in it.
Mhm.
Yeah.
Yeah, no, thank you for the opportunity. And, I mean, there is a lot to be done, and the nice thing is that for young people like you, no matter what discipline you go into, whatever area you work in for your degree, be it
Mhm.
social sciences, be it engineering, be it medicine, be it economics, be it English literature, it doesn't matter, what you do. In every discipline, there is an opportunity to do something towards sustainability,
Mm. Yeah.
right? So that provides kind of that common, type of goal and
Mm.
opportunity. So, I hope more people realize that and work, towards that.
Yeah. Um,
So,
yeah, thank you
okay.
again.
Yeah, and thanks for the opportunity. Really appreciate the time that you spent on this and your interest. And if there is any further information you or anybody else needs, I
Yeah.
mean, I'm easy to find online. Feel free to
Yeah.
get in touch.
I'll definitely reach out.
Okay. All right.